Let's talk about multiplication again. When we multiply a number, we actually add it starting with 0, believe it or not. In mathematics, really, when you think about it, pretty much everything is based off zeros. So for example, 7 times 3. We're actually starting with 0 and adding 7 3 times, end up at 21. 7 times 2, we're starting with 0 and adding 7 twice, end up with 14. 7 times 1, we begin with 0 and add 7 once to end up with 7. In other words, when you're adding a number, you're actually starting at 0. Or when you're multiplying. 9 times 3, for example, it's 0 plus 9 plus 9 plus 9. In other words, you have to start somewhere, and you start with nothing, which is kind of a fascinating concept in and of itself. So, all that to say that if we multiply 7 by 0, we do still start at 0, but guess how many times we add 7? None, right? Well, if we don't add 7, we end up with 0, if we don't add it at all. Therefore, 7 times 0 is 0. Let's look at a negative number. Negative 1 times 3, start at 0, add negative 1 3 times, we end up with negative 3. Or you could say subtract 1 3 times. Negative 1 times 2, start at 0, subtract 1 twice, you end up at negative 2. Negative 1 times 1, start at 0, subtract 1 once, end up at negative 1. Negative 1 times 0, start at 0, subtract 1 no times, so in other words, really nothing goes here. And if we don't subtract 1 at all, then we stay at 0. Therefore, negative 1 times 0 is also 0. We looked at pi before. Let's look at it again. It's a special number. Pi times 3, add pi 3 times from 0. You end up at 3 pi. Pi times 2, add pi twice from 0. Pi times 1, add pi once from 0. Pi times 0, add pi 0 times from 0. So again, we don't put a pi here. There's nothing there. And if we don't add it at all from 0, we stay at 0. Therefore, pi times 0 is also 0. We can do the same thing for fractions and see that 1/2 times 0 is the same as saying we're going to add 1/2 0 times, so we're not going to add it at all. Therefore, 1/2 times 0 is 0. In general, any number, let's say a represents any number. If we add a 3 times, we end up with 3a. If we add a twice, we start at 0 and add a plus a, which gives us 2a. If we add a once, we start at 0 and add a once and end up with a. That was, by the way, the identity property of addition. And if we add a 0 times, it'd be a plus basically nothing, right? So therefore, any number times 0 is 0. Another way of looking at it, let's go back to the money example. If you have, let's say we say to ourselves we have one $10 bill. It's the same as 10 times 1, which is 10. We have $2 $10 bills. That's 2 times 10, which is $20, and the same for 3. Well, if you say up here you have 0 $10 bills, I have 0 $10 bills, that's 0 times 10, and you have no money whatsoever, okay? So maybe the money example helps you multiplying by 0. Basically, if you multiply anything by 0, no matter how complicated it is, you are going to end up with 0. So therefore, a times 0, where a is any number or any expression at all, is going to give you 0 back. Let's do some examples together. 500 times 0. What is 500 times 0? 500 seems like a really big number, right? So maybe something else goes in there. No, it doesn't matter how big the number is. When you multiply by 0, you have 0 of that thing. Therefore, the answer is 0. Okay. I remember asking this question when I was a little kid in elementary school. 0 times infinity. So just imagine if I take 0. So if I'm adding it infinitely many times, that means I just keep adding and adding and adding and adding and adding and adding. And I'll never have enough time in the world to add it infinitely many times, because infinity goes on forever, right? But just notice, no matter how many times I add 0, I'm still going to get what? I'm still going to get 0, right? And so it kind of seems like a daunting problem, right? But really, it doesn't matter how many times you add 0, it doesn't matter what number you multiply it with, including infinity. And by the way, this means infinity. Some of you might not know that. And what infinity basically means is the biggest number you can possibly imagine. Which, by the way, if you pick a big number, your friend next to you can pick a bigger one, so it's more of a concept. But still, doesn't matter how many times you add 0. Infinitely times you'll still end up with 0. Therefore, 0 times infinity is 0. How about negative 792 times what number gives you 0 back? Well, it's not 1, it's not 2, it's not 3, it's not any negative number. You can only multiply one number to get to 0, and that answer is 0. You guys might start to see a pattern here. If you multiply 0 by something, you get the same thing, right? 0. Same thing for negative 2.718. Negative 2.718 times 0 is equal to 0. Here's another fraction problem. 5/8 times 0 is equal to what? If you said 0, you are correct. And this is just testing you on the identity property. A times 0 is equal to any number. Remember, A means any number. Any number times 0 is going to give you what? 0. That is the 0 multiplying by 0 property. There's something in math called the 0 property, which is a little bit different than this. It's kind of the same thing, so you could call it that. But alright, what if you take x, which represents any number? What would you have to multiply in order to end up with 0? Okay, and at this point you guys are probably really getting it and want to move on. Let's do a few more though. Let's say you have x times y times z. So you have 3 different numbers. You multiply them together. You can imagine in your head whatever those 3 numbers are, and you multiply all that by 0. Well, notice if you multiply these 3 numbers together, you're still just going to get a number back. Let's call it n. And if you multiply that by 0, it's still just a number, right? See, sometimes in math we see all these letters and we psych ourselves out, but all those letters just represent numbers. And if you multiply a bunch of numbers together, you still just get a number. So keep that in mind in case you feel tempted to get confused. Same thing with this. You might not even know what this expression means. I'll read it for you. 33x squared minus 9y squared times 0. Now I'm showing you that it doesn't matter how complicated the expression is, okay? This is a very complicated expression, but we're still multiplying it by 0. And therefore, it doesn't matter how complicated it is, when we multiply by 0, we end up with 0. Including this one, which looks really funky. I just used a bunch of random symbols here. I can't even pronounce them. But if you multiply them by 0, whatever numbers they represent, you're still going to get what? You're still going to get 0. And I do this a lot just to show that it doesn't matter what you put there, okay? You can literally write a sentence in English. I don't care what you do. As soon as you multiply that by 0, it's 0. And hopefully I'm driving this so much so that it clicks in your brain, so that from now on, when you see this, and you will see this a lot in mathematics as you work out problems, anything times 0 is 0. And guess what? It also includes 0. This is kind of a weird one, but if I'm adding 0 times, I mean, it is kind of weird, but even young kids understand this one, right? That's got to be 0. Again, this is a lesson in which when you multiply any number by 0, you end up with 0.